Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will do the integration by trigonometric substitution of the integral below. And I think this is the last, because I did a lot of example for integration by trigonometric substitution. I think this is the last one that I'm gonna do, and we will go to other subjects unless I receive the comments that somebody want more, or if I receive like requests for more integration by trigonometric substitution, then I will do more. As usual, before I solve this problem, I will give you a hint on how to solve it. I know if I have the formulas a2 minus x2, then I will take x equal a sine of x or a sine of theta, and I will use the formula cosine square of theta equal 1 minus sine square of theta. If I have square root of a square plus x square, I will use x equal a tan of theta, and I will use the trigonometric identity formula sec square of theta is equal 1 plus tan square of theta. And if I have square root of x square minus a square, so this is x square minus a square, which is what we have in this example. I will use x equal a sec of theta, and the trigonometric identity formula tan square of theta is equal sec square of theta minus 1. So now let's start solving this problem. Here I have x square minus 3 square, which is x square minus a square. So I take my x is equal, I don't need a square, I need a, so it is 3 sec of theta. So my dx would be 3 sec of theta tan of theta d theta. And let's highlight this. I took that, so we will use it. And now let's replace my integral, my x and dx in the integral by their values. So my integral will become square root of x square, which is 3 square is 9, sec square of theta minus 9, divided by 3 to the power of 3 is 27. Sec to the power of 3 of theta, and instead of dx, I will write 3 sec of theta tan of theta d theta, that I got it from here. So here I can factor out 9, and I will take it outside my square root as 3, because square root of 9 is equal to 3. So this becomes 3 square root of sec square of theta minus 1. So I factored out 9, so it become 9 parenthesis sec square of theta minus 1, and then I took out the 9 outside the square root as 3. This is what I did, time 3 sec of theta tan of theta d theta. But like I know I have 3 times 3 is 9, let's write it as 9 right away so we save some times. So I'm gonna write it 9 here, divided by 27 sec to the power of 3 theta, and I have the d theta on top. So now I know 9 divided by 27 is 1/3. So I can take 1/3 outside my integral, and I will use the trigonometric identity formula that I'm highlighting here. Tan square of theta is equal sec square of theta minus 1. So that sec square of theta minus 1, I can replace it by tan square of theta, and square root of tan square of theta is tan of theta. So I would have tan of theta, and here the sec with sec to the power of 3, it becomes sec to the power of 2. I have sec to the power of 2 theta times tan of theta. So tan of theta times tan of theta is tan square of theta d theta. Now I know that tan of theta equal sine of theta divided by cosine of theta. So tan square, I would have sine square of theta divided by cosine square of theta. And in the denominator, I have sec to the power of 2 of theta, and then I know the sec is 1 over cosine to the power of 2 of theta, and then I know the cosine. No, let's keep it that way. So my integral become integral 1/3 here. Instead of tan square of theta, I will write sine to the power of 2 theta divided by cosine to the power of 2 theta, and divided by sec square of theta. So this divided by, let's put it like that, divided by 1 over cosine square of theta d theta. But I know the division, it become multiplication, but I have to flip the second fraction. So let's do it right away. I just put it for you to see it. So instead of 1 divided by cosine square of theta, it becomes cosine square of theta divided by 1. So now I can simplify cosine square of theta and cosine square of theta. So my integral become 1 over 3 integral of sine square of theta d theta. And here I want to use a trigonometric formula, a trigonometric identity formula that says sine square of theta is equal 1/2 times 1 minus cosine of 2 theta. This is a formula, you can use it. So I will replace my sine square of theta by 1/2 times 1 minus cosine of 2 theta. So the 1/2, I can take it outside my integral. It become 1/3 times 1/2. It is 1 divided by 6. And it become d theta. 1 times d theta is d theta minus 1 over 6 integral of cosine of 2 theta d theta. I know the integral of t theta is theta. So I will have 1 over 6 theta minus 1 over 6 integral of cosine of 2 theta d theta. And here I say let u equal 2 theta. So du equal 2 d theta. So d theta is equal du divided by 2. So my integral here, it become, I will keep 1 over 6 theta minus 1 over 6 integral of cosine of u times du divided by 2. And the 2 would go outside as 1 over 2. So I would have 1 over 6 theta minus 1 over 12. And the integral of cosine u is sine u. But I know that u is equal to 2 theta. So it becomes sine of 2 theta plus c. And here I will use another trigonometric identity formula that say sine of 2 theta is equal to 2 sine theta cosine theta. So I will replace sine 2 of theta, this is 12 here. 2 times 6 is 12. That 2 times the 6 is 12 not. So I will replace sine 2 theta by 2 sine theta cosine theta. So the solution will become 1 over 6 theta minus 1 over 12. Instead of sine 2 theta, I will write 2 sine theta cosine theta plus c. So this 2 and this 12, it become 1 over 6. So it's 1 over 6 theta minus 1 over 6 sine theta cosine theta plus c. And here I will draw my famous trigonometric triangle. So, and this is my theta. And if you remember at the beginning, we took x is equal 3 sec of theta. So we took x is equal 3 sec of theta. So sec of theta is equal x divided by 3. So my theta is equal sec minus 1 x divided by 3. And I will use it to replace this theta here. But I know, and then I take sec of theta equal x divided by 3. I know that sec is equal 1 divided by cos of theta. It is equal x divided by 3. So, and I will do cross multiplication. I would have 3 equal x cos of theta. So my cos of theta is 3 divided by x. And I know the cos is the adjacent divided by the hypotenuse. And if I look at my triangle, the adjacent of theta is this, and the hypotenuse is that. And so this will become the original x squared minus 9. So now sine of theta is equal square root of x squared minus 9 divided by 3. And cosine of theta, we said it's equal x divided by 3. 1 minute. Did I do a mistake here? The adjacent is 3 and the hypotenuse is x. Here, I did a mistake here. The adjacent is 3 and the hypotenuse is x. The adjacent is 3 here and the hypotenuse is x, and that's the hypotenuse. Sorry for that. So sine, it becomes square root of x squared minus 9 divided by the hypotenuse, which is x now, not 3. And the cosine of theta, because I was looking here, cosine of theta it's supposed to give me 3 over x, and from what I draw, it was giving me x over 3. So it is adjacent to is 3 divided by x. So now I go back to my solution here, and I will replace theta and sine of theta and cosine of theta by their value. So I would have 1 over 6, and we said theta is equal sec minus 1 x divided by 3 minus 1 over 6. It was sine of theta, cosine of theta, yeah. So the sine of theta is square root of x squared minus 1 divided by x, and the cosine times 3 divided by x plus c. So you can put this x squared and you can simplify by the 3 here. Let's do it. 1 over 6 sec minus 1 of x divided by 3, and this, it become minus 1/2 square root of x squared minus 9 divided by x squared plus c. And that's my final answer. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.